and welcome to day 3 of your final exam review. Thank you for tuning in. We are glad to help you with your college algebra needs here on YouTube. So let's get right to this. Are we ready, folks? Okay, I thought so. Solve the following inequality problem. We've got, this is given to us in steps or in parts on our test. Part 1, we're supposed to describe the solution set for the first linear inequality. So we're just looking at the first inequality, and it wants us to give our answer in interval notation. So looking at this, I will begin by distributing the negative 5. So that gives me negative 5w plus 5 is less than or equal to 35. Solving the inequality, we're going to subtract a 5 on both sides, giving me negative 5w is less than or equal to 30. And then I'm going to divide by negative 5. And what happens anytime we divide by negatives? Flip the inequality around. So instead of less than or equal to, we get greater than or equal to. 30 divided by negative 5 is negative 6. So w is greater than or equal to negative 6. If you're still struggling with interval notation, go to a number line. We understand number lines. There is 0. Here is negative 6. Greater than or equal to negative 6 means we can equal it, and we can go shade to the right. So in interval notation, this will be square bracket, negative 6 to positive infinity. Okay, part 2 of the questions is to describe the solution set for the second linear inequality using interval notation. So looking at the second one, 11 minus w is less than 13. We're going to subtract an 11 on both sides, leaving negative w is less than 2. Divide by negative 1. And that gives me w is, flip the inequality because we divided by a negative, greater than negative 2. On a number line, that would mean negative 2 is here, greater than negative 2. Would be a curved bracket, so not including the negative 2, but shading everything to the right. So our interval notation will be curvy bracket, negative 2 to positive infinity. Okay, in part 3, it asks us to describe the overall solution set using interval notation. And we have to consider here the word that joins our compound inequality. We're talking about the word and. So we learned that the word and has a specific meaning and the word or has a specific meaning. Do you remember the two meanings?
You put the wrong graph on one.
Yeah, there's negative 2 and negative 6.
Oh, you're right. I put the wrong graph on there. Okay, pretend that's not there. But what does the word and mean?
Intersection.
And means intersection. What does or mean, by the way? Union. Okay, so we want to know the intersection of the two answers that we got. There are two inequalities graphed here. We want to know the intersection of the two. So intersection means if I were to take one and put on top of the other, what would be shaded by both graphs. So where could we say that these two graphs are intersecting each other? From negative 2 to infinity. So if I were to take this blue graph and put it on this same graph that I have the red one, negative 2 would be right in here, right? And negative 2 to infinity would look like this. So where do the blue and the black intersect? Only from negative 2 to infinity. So describe the overall solution set using interval notation. This is the overall solution set. It is just the intersection of the two graphs from negative 2 to infinity. That is the intersection of the two graphs. So on part 4 of this question, it asks us to describe the overall solution set by graphing. Paying attention to the fact that we have a curvy bracket on the negative 2, we would choose curvy bracket and curvy bracket here. Here's the correct answer. And you also have to choose a curvy bracket to be able to shade all the way to infinity on this number line. We know that, right? Okay. Okay, the next question gives us a rational function. Rational meaning fractional. Rational functions are functions that have variables in the denominators. First part, find the equations for the vertical asymptotes, if any, for the rational function. To find equations of vertical asymptotes, we have to first factor anything in the numerator and denominator that can be factored. Okay, so first we factor, if possible. Is there anything here in the numerator and denominator to factor? No, there's nothing here that needs to be factored. These are both linear factors. But the reason we do factor is because sometimes something in the numerator can cancel with something in the denominator. Okay? So factor first if possible. In this case, we don't factor. Then we will say set denominator equal to 0 to find vertical asymptotes. Okay, so the denominator is x plus 9. Set it equal to 0. Subtract 9 from both sides. Vertical asymptote at x equals negative 9. Vertical asymptote at x equals negative 9. Now, when we input that, if there are multiple answers, we would separate them with a comma. It's possible to have multiple ones if we have, like, say, x plus 9 and x plus 8. Then we would set both of those equal to 0 and solve for the multiple vertical asymptotes. Okay? All right. Okay, the next part asks us about the horizontal or oblique asymptotes, oblique meaning slanted asymptotes. We have some rules. There were 3 cases that I had you consider with horizontal or oblique asymptotes. We had case 1, case 2, and case 3. Does anybody remember how we differentiated between these different cases? It had to do with the degrees. Okay, if the degree of numerator is higher, then we would say no horizontal asymptote, C oblique. There may be an oblique asymptote. Okay? Do you remember that graphic organizer we created? It's on the paper, and I'd done it in a Sharpie. We had a video of it. Okay. All right. Case 2 is when the degree of numerator and denominator are equal. And in that case, we get a horizontal asymptote at y equals the leading coefficient of the numerator divided by the leading coefficient of the denominator. Case 3. Case 3 would be when the degree of the numerator is less than the degree of the denominator. And in that case, every time we have a horizontal asymptote at y equals 0. So those were the 3 possibilities. You've got to look at this given rational function and decide what case is this. Check out your degrees. What case? Case 1, case 2, or case 3, folks? Case 2. The degree of the numerator is 1. We're talking about the highest power of x. The degree of the denominator is 1. So we're going to get leading coefficient, which is the coefficient of x, divided by leading coefficient, which is coefficient of x. We're going to get a horizontal asymptote at y equals 1 divided by 1, which is 1. Horizontal asymptote at y equals 1. It is important to remember that horizontal asymptotes and oblique asymptotes start with a y equals, whereas vertical asymptotes start with x equals. And if you leave that out, When you input that, it's going to count you wrong. Okay? Okay, now, the last part of this question, you have to enter 4 ordered pairs that go on the graph of this rational function. So we're going to have 4 ordered pairs, and this is fairly easy. Pick a number, any number. I love zeros. So if I input a 0 for x's, then I'm going to get 2 over 9 for the y coordinate. So there's 1 ordered pair. I also like the number 1. So if I input a 1, then I'm going to get the fraction, let's see, 1 plus 2 is 3, 1 plus 9 is 10, 3 over 10. Oh, why not just go with it? I like the number 2. So 2 plus 2 is 4, and 9 plus 2 is 11, and I like the number 3 as well. So 3 plus 2 is 5, and 3 plus 9 is 12. So there's 4 order pairs that are on the graph of this rational function.
We can't use the vertical asymptote.
Remember when you're inputting your x coordinates that you cannot use the x value of the vertical asymptote. So I was free to pick any number here, except I was not allowed to pick 9. I mean, negative 9. Alright, in this problem it says to use the elementary properties of logs to solve the following equation. Enter your answer as a fraction, reduce to lowest terms. So here I have a single logarithm. It's written as a single log. When I'm solving log equations, I want to condense so I have a single log on both sides. Well, this time there's only a log on one side, and it's already condensed. So my next step, since it's already condensed and I have a single log on one side, is to write in exponential form to solve. So the exponential form here is going to be 2 to the third power, 2 being the base, 3 being the power, is equal to 64 to the 2x. Now when I see the number 64, I know that that's a power of 2. I know 2 to the 5th is 32, so 2 to the 6th would be 64. 2 to the 6th is 64. So what I've been able to do here is make the basis match. Use the properties of exponents and say that this is 2 to the 12x, because I can multiply powers, equals 2 to the third. And now, since the bases match, I can say that the exponents 3 is equal to the exponent 12x. Divide by 12. 3 divided by 12 is a fraction that reduces to 1/4, and it did say to give your answer as a fraction reduced to lowest terms. So 1/4. Okay, this particular problem says to solve the following quadratic-like equation. If needed, submit your answer as a fraction reduced to lowest terms. Okay, so it's quadratic-like because we have a quantity that's squared plus a coefficient times that same quantity, but the second time the quantity is to the first power, minus 30 equals 0. In order to solve this, we're going to let capital A equal y squared minus 6. That quantity is going to be substituted with capital A. So I'm going to write this as capital A squared plus 7 times capital A minus 30 equals 0. So now I want to know what are factors of negative 30 that would give me a sum of 7. Ten times negative 3 multiply to be negative 30, but add to be 7. So I will factor this quadratic function with my capital A as a plus 10 times a minus 3. And that's all set equal to 0. Next, zero product property says set each of these factors equal to 0 and solve. So capital A equals negative 10 and capital A equals positive 3. Now, careful here because the question asks you to give first set of solutions and second set of solutions, and a lot of times people want to give this for your first set of solutions. This is not a solution. This is still on the way to a solution, okay? Capital A now has to be substituted with what we said it equals. So I don't have a solution until after I have substituted for capital A. Capital A is y squared minus 6. So y squared minus 6 could be said to be equal to negative 10. And y squared minus 6 could be said to be equal to 3. Now solving the first quadratic, I'm going to add a 6 on both sides. And I get y squared is equal to negative 4. And then I'll take the square root of both sides. So y would equal plus or minus what? 2i. There's your first set of solutions. 2i and negative 2i. Your second set of solutions comes from this. Add a 6 to both sides. Y squared equals 9. Take the square root. Y equals plus or minus 3. So my two sets of solutions, well, first set is 2i and negative 2i. My second set is 3 and negative 3. And there's a separate box here for every answer to go in. Okay? So there are 4 solutions. Again, I will warn you, the biggest mistake is people want to give this as the first set of solutions. This is not the solutions. You get the idea? Okay, don't make that mistake. Okay, so this particular equation says solve the following exponential equation. Write the answer as both an exact expression and as a decimal approximation rounded to 2 decimal places. So you have to enter the answer 2 ways. To begin, we're going to isolate our e by dividing both sides by 2. That's going to be helpful because when we have e to a power, we're going to be able to take the ln of both sides. 88 divided by 2 is 44. Now, when we solve an exponential equation, what we have learned is we prefer to try to make the bases on both sides match. And if we can make the bases on both sides match, then we can set the exponents equal to each other. That's not going to work here because I cannot write 44 as e to a power. So since I cannot write 44 as e to a power, what I will do instead is take the ln of both sides. I'm taking ln instead of log because ln of e will cancel. So take the ln of both sides. As long as you do on one side what you do on the other, you're in good shape. So, ln of e cancels. I'm left with 4x plus 9 equals the ln of 44. I'm trying to isolate x. What do we do? Subtract 9 on both sides. So that gives me 4x equals the ln of 44 minus 9. Then we divide by 4. And this is going to be my exact answer. Because remember, it asks for the answer 2 ways. Exact and approximated. So here's the exact answer. ln of 44 minus 9 divided by 4. There's the exact answer. The approximated answer, you're going to type that into your calculator and round it. And it says to 2 decimal places. So take a minute and type that in the calculator. So our approximate answer is negative 1.30. Okay, this question asks us to find the standard form of the equation for the circle described below. I'll remind you first what the standard form of an equation of a circle looks like. That is x minus h squared plus y minus k squared equals r squared, where the center of the circle is hk and r is the radius. Okay, this gives me the information that the endpoints of the diameter are 10, -3, and -4, -9. If those are endpoints of the diameter, we know that a diameter has to travel through the center. To find the center, since it is the center, we can find the midpoint of those two endpoints of our diameter. So find the midpoint of the two endpoints of the diameter. So the midpoint finds the average of the x's. So add up the x's, 10 plus -4, and divide by 2. And it finds the average of the y's. So add up the y's and divide by 2. -3 plus -9 divided by 2. This is how we're going to find the center. So our center of our circle is 10 plus -4 is 6, and 6 divided by 2 is 3. -3 plus -9 is -12, and -12 divided by 2 is -6. Our center is the point 3, -6. Okay, so let's talk about what we know. We know that x minus 3 squared plus y plus 6 squared, notice the sign change because it will be minus a negative, equals my radius squared. Right now, I do not know the radius. There's a couple of ways to approach this. I can use the distance formula and say I'm going to find the distance from the center to either endpoint. That distance is going to be the length of the radius. Or you can use the circle formula that you're already given here and substitute a point on the circle for x and y. That's going to be my approach here. A point on the circle, I'm going to say 10 and -3 are x and y. Okay, I could use -4 and -9. I'm just going to use the first one, 10 and -3. So if I substitute for x, 10, and I substitute for y, -3, I can solve for r squared. Okay, so 10 minus 3 is 7 squared. -3 plus 6 is 3 squared. 7 squared is 49. 3 squared is 9. So r squared, the radius squared, 49 plus 9, is 58. R squared is 58. That's the number that actually goes into the formula. The radius would be the square root of 58. The r squared is what goes into the formula. So what the question asked me for was the standard form equation of the circle. So standard form equation is going to be x, go back to what I found, minus 3 squared, plus y, go back to what we have found with the center, plus 6 squared, equals r squared, which we just found to be 58. Here is the answer. This is the standard form equation of the circle that goes through those given endpoints of a diameter. Okay, the next example asks us to solve another quadratic-like equation. Submit your answers in fraction reduced to lowest terms if needed. So this is another quadratic-like. Anytime we have a quadratic-like equation, what we're looking for, what we're going to see is that the first term is a particular power that is double that of the power of the second term. So 2/3 is double of 1/3, right? 2/3 is twice 1/3, or 2 times 1/3 is 2/3. So what we are seeing here is that we are going to let capital A equal y to the 1/3 power. Capital A is going to equal y to the 1/3 power. If you go back to the last quadratic-like problem that we did, just remind you, we let capital A equal this middle power, right? This middle quantity, which is raised to the first power. It's the same idea here. You see the similarity? It's the middle power there. Okay, so those are some similarities. Even though this one has fractional powers, it's still set up the same way. Okay, so what does that mean? That means that this is 3 times capital A, and if y to the 1 power is or sorry, y to the 1/3 power is a, then y to the 2/3 power is a squared. Okay, this is beautiful because it has a leading coefficient, and so I can either factor by AC or go straight to the quadratic formula. So everybody's saying quadratic formula. Okay, so we'll go to the quadratic formula. X equals, I'm singing on YouTube, guys. X equals negative b, that's going to be negative 10. Plus or minus radical b squared, that's 10 squared, minus 4ac, all over 2a. Okay, let's calculate the number that comes under the radical, that is the discriminant. So x is going to equal negative 10 plus or minus, let's see, 10 squared minus 4 times 3 times 8. What is that?
2.
Exactly 2?
Yeah.
Or the square root of it's 2?
The square root is 2.
Oh, so it's 4. So this is 4. Is that what you're telling me?
Yeah.
Okay.
I just typed it all in.
With the square root?
Yeah.
You typed the whole thing? Or this whole thing?
The whole thing, like the square root and everything under it.
You typed that in your calculator. Okay, so that's square root of 4 then. So you're going to get x equals negative 10 plus or minus 2. Is that what you're telling me?
Mm-hmm.
Okay, great. Over 6. So to get my two answers, I'll say negative 10 plus 2 over 6 and negative 10 minus 2 over 6. So negative 10 plus 2 is negative 8. Negative 10 minus 2 is negative 12. Negative 8 over 6 is a fraction that reduces to negative 4/3. Negative 12 over 6 reduces to negative 2, or divides to be negative 2. Now this is what x equals. Not x. Capital A. This was capital A. This was all variable capital A. So let me go back and fix that. This is what capital A equals. Now, is that what we were supposed to solve for? No. We were supposed to solve for y. Okay? So, since capital A equals y to the 1/3, substitute now. Capital A is really y to the 1/3. Okay, how do I undo the 1/3 power? You are so right. Sorry, that's a negative 2. Thank you. Okay, how do I get rid of a 1/3 power? Cube it. Raise to the 3rd. So I'm going to raise both sides to the 3rd. That cancels the 1/3. Negative 4 to the 3rd power is negative 64. And 3 to the 3rd power is 27. Also here, we're going to cube it. Negative 2 to the 3rd power is negative 8. So these are two answers. I did raise both sides to a power. It is sometimes possible to introduce extraneous solutions when we're raising to power. Let's see what the original problem said in the directions. It said, solve, if needed, submit your answer as a fraction reduced to lowest terms. Let's go back here. I'm on the wrong problem. Okay, it is asking for two answers here, negative 64 over 27 and negative 8. It doesn't say anything about you might not use both boxes. You see how that is not in the directions? Therefore, if there's two boxes there, you're going to go ahead and use both. So negative 64 over 27 and negative 8. Questions? Okay, next question. Use polynomial long division. It's our favorite. It's our favorite. We love long division. We love long division. To rewrite this fraction. Okay, let's just get into it. We love long division, don't we? Hey guys, we can use synthetic on this one.
Okay.
You want to use synthetic?
Yes.
Yeah. What tells me I can use synthetic? It's x to the first power and it has no leading coefficient. You could use synthetic here. -4 is the multiplier. Write the coefficients. 1, 11, and -7. Oops, sorry. Sorry. Y'all told me I have 6 minutes, so that's turbo speed. Okay, begin by bringing down the 1. What happens now? Multiply. -4 times 1 is -4. Add down. Multiply. Add down. Okay, the last one is the remainder. Our dividend started with a power of 2, so our answer is going to go 1 power lower. So x to the first, and this is a constant. So our final answer is x plus 7 minus, our remainder is 35 over x plus 4. Shoot. Because we're overachievers, we're going to the next one, and then we're going to call it quits for the day. Okay, consider this function. Find a formula for the inverse. Inverse, inverse, inverse. Step 1. Let's just do it. Step 1, replace f of x with y. Y equals -x plus 2 over -x minus 5. Step 2, switch your x's and your y's. All your y's become x's, all your x's become y's. Step 3, solve for y. Put a 1 under it. I'm going to cross product. Okay? I'm going to cross product here. That gives me -y plus 2 equals -xy minus 5x. I'm solving for y. Put any term that has a y on the left. Put any term that does not have a y on the right. Okay? So get the y's together. So -y plus xy is going to equal, because I brought this one over, I'm going to bring the positive 2 over, and it's going to become -2, right? So -5x minus 2. Factor y. Right? Okay. So that leaves me with -1 plus x. To get y alone, what do? Divide by -1 plus x. Divide by -1 plus x. That gives me y equals -5x minus 2. And I just about bet you're going to like the way it looks better if I put x minus 1.
Yeah.
So this is your inverse. Once you get the y alone. -5x minus 2 over x minus 1. And we'll call it a day there, folks. Well, if you'll tune in tomorrow, we'll try to finish up this never-ending final exam review for your college algebra final. Thanks for tuning in.